Today, today we want to talk about basic geometry, and I just want to give you a tip. And geometry is all about a science of mathematics whereby we locate points, curves, segments, and finding locations of any object or any movement on a graph or on a Cartesian plane. So now, before we proceed, I need to tell you that geometry is divided into two parts, and the first one is the Cartesian coordinate. The Cartesian coordinate, and that is what we are very much familiar with from our secondary school days, and that is when we plot our graph, our x and y graph. For example, if you remember in your secondary school days, you have something like this. Remember, you have this as a y-axis and your x-axis. Let's say, for example, we want to locate a point. Let's call the point 5, 3. Now, they can tell you to locate this point on a Cartesian graph or a Cartesian plane, and if you want to locate this, with respect to this, that means this is our x and this is our y. Now, my x is 5 and my y is 3. For me to locate this point on the graph, that means I will trace my point. So you can draw your scaling. Don't mind our scaling here. It's just so hard, but you will understand what we are trying to pass across here. Then you can draw this other scaling for your y-axis. It should be 1, 2, 3, 4, 5, and 6, like that. So now, on our x-axis, we have 5. So you can trace it up. Then on our y-axis, we have 3. Then you trace this out like this. So the point they want us to locate is right here. So that means this is the point 5, 3. Very simple like that. And the second part is the polar coordinate. Now, when we talk about polar coordinate, that means we deal with angles. We set a location of an object or a point with angles. Now, when we say angles, what do we mean? Something like this, and we have the relation, which is the r, and then we have the angle. You can use anything to denote your angle. You can use alpha, you can use beta, or any symbol. Now, if I have this point, let's take, for example, they want me to locate this point P of let's say 4 and pi over 4. I want to locate this point on my Cartesian graph. Now, this is the r, which is the relation with the angle, and this is the angle. Now, how will I transform this angle, and how will I locate it on my point? We all know pi is 180. You need to know that pi is 180. Now, getting this side, that means you want to divide 180 into 4 places, and that will simply give you 45. Now, that means we have 45 degrees on this part, and then we have our r to be 4. Now, let's take this as our example. When you draw your Cartesian graph, this will be your y-axis and this will be your x-axis. Now, when you do this, then you can give your scaling. You can give your scaling on any scale you want. You can use it 2 units for 1 centimeter or anyhow, depend on how you want to draw your graph. Then you check it very well. From this place to this place, we know this is the first quadrant, which is having 90 degrees. And what we have here as our degree is 45 degrees. So that means we'll simply do we divide it into 2. That means this side is the angle 45 degrees. We count it to this side, towards the side, the clockwise direction. And then the r is 4. This is our r. So this is how we locate the point. So that means the point is somewhere around here. So that is that. Now, let's move to the next side, or the next subtopic for today, and that is transformation. Transformation from Cartesian to polar coordinates. Yes, transformation from Cartesian to polar coordinates. Now, if I want to do that, let's take, for example, I have this example. Let's say we have let's say 3, 4. I want to change this to polar. I want to change it to something like P into R, then angle. Now I want to change something like this. Now if I want to do this, this is very simple. Plot your graph for this Cartesian distance. Then you have your y here, you have your x here. Now this is 1, 2, 3. So your x will be somewhere around here, and then your y, 1, 2, 3, 4. You see, these are 4, these are 3. So if you join it together like this, the point will be here. So this is the point we are looking for. Now if you draw it here, so you can draw these dots, and then you make this visible. Now if we do it like this, this is the triangle we'll be working with. So from here to here is what, 3, and then from here to here is what, no, I mean from here to here is what, 4. So if this place is 4, that means this place is also what, 4. Now if you want to get the r, this r, how do we get that? That's very simple. If you remember, this is what, a right-angled triangle. So we have a 3 here, we have a 4 here. For us to get this r, what we do is what, r squared is equals to what, 3 squared plus 4 squared. And then our r squared is equal to what, 9 plus 16. Then we have our r squared to be equal to what, 25. Then our r is equal to what, 5. That is the square root of both sides. The square root will call this square, and then this will call this to be what, 5. Now that is our r. Now for us to get the angle, how can we get the angle? This is the angle relating to the what, x-axis. Now how can we get this angle? If you remember your SOHCAHTOA, the sine, cosine, and the tan angle, and that is what, if you want to get the angle here, we have been given these two sides. This is our opposite side, this is our opposite side, and this is our what, adjacent side. So we need to make use of these two. Then what we simply do is, since we have opposite and adjacent, remember your tan theta equals to what, opposite over adjacent. Then for you to get that angle, you can call it theta, you can call it alpha, either of the two. Let's make it alpha since we are using alpha here from the beginning. So we can say this tan alpha equal to what, opposite. What is our opposite? 4 over, and then my adjacent is what, 3. So now if you want to do this, we are looking for this angle, so you cross multiply. Then we have 3 tan alpha equal to what, 4. Now I'm looking for my what, this angle. So then we can divide both sides by 3. We divide both sides by 3. Then we have tan alpha to be equal to what, 4 over 3. Then if you want to get this, this is what I'm looking for, not tan alpha. So my alpha will be equal to what, the inverse, which is arctan of what, 4 over 3. So the arctan of 4 over 3 will then give us what? Will then give us what? Tan inverse. So finding the arctan of this will be 1.33333. Just pick 4 of them like that, and then finding the arctan of 1.33, that will give us 0.9273 approximately like that. So that means our angle there is 0.923. So in short, in brief, what you can quickly do if you want to find the angle, like you want to change from Cartesian to what, to polar, you don't need to do all this tan or inverse. What you just need to know is what, you know that the formula is tan angle, the angle to be equal to what, the y given over x. So now that will be what, the tan angle to be equal to what, the y you are given in the question and the over the x. So if you do it like this, you quickly get your answer, but this is just for better clarification. So now if you want to change from Cartesian to polar, that means you will have to do with what, with this angle. And after dealing with this, you get your angle, which is the angle here, and then to get your r, you need to use the what, the the Pythagoras theorem. So I think that is clear enough. Now let us do what? Let us convert or transform from polar to Cartesian. Now let's take the example we have here. Let's say the polar we have here is 4, pi over 4. I want to change it to something like p into x, y, like this. Now this is angle. I hope you know that. I want to change it to just x and y axis. So now what do? If you want to change it to that, now let us plot a graph for better clarification. This is y and this is x. let's say this is our 0. Let's say we have a 4, and let's say we have the angle to be pi over 4 here, and then we have our r to be 4 here. Now, if this is our x-axis, now if you want to plot this graph, just trace this down. That means with this we can denote a right angle triangle from this. Now this will be our what? R, which is our hypotenuse. Then this is our y, and this is our x. So now you can get that done by doing what? By simply solving for your x using the SOHCAHTOA. When I say SOHCAHTOA, it means this. Now that means sine angle will be equal to what? The opposite of hypotenuse. Cos the angle will be equal to what? Adjacent over hypotenuse. Tan the angle will be equal to opposite over adjacent. Now if I want to calculate for x, if I want to get my value for this x here, what will I do? I need to find one of these angle that will give me the value of x. Now me looking at this, I have my what? My hypotenuse, and this is my adjacent if I'm using this angle. Now I have hypotenuse and this is adjacent I'm looking for, and then I have this angle. So we can see that this is the preferred angle I will use. Now how would I do that? That means that we have cos pi over 4 to be equal to what? Adjacent, which is my x, over my hypotenuse, which is 4. Now if I get this done, you can equate it to make them to be equal fractions like that. Then you cross multiply. Then your x will multiply this. Why are we cross multiplying? We are cross multiplying because we want to what? Make x subject of the formula. So then we do x will be equal to 4 times cos pi over 4. Now our x will be equal to what? Pi over 4, I told us it is 180 divided by 4. And that will give me what? 45 degree. So that means I have 4 times cos 45 degree. And if you get that in your calculator, what is cos 45 degree? That will give us what? 0.5253. Then multiplying your answer by 4. What do we have? We have something like 2.63. Let's convert that to the nearest 2 decimal places. So my x is what? 2.63. Now calculating for my y. Well, let's round this up to the nearest whole number. Let's say this is what? 3. Now calculating for my y, from this diagram here, my y is needed. How can I get my y when I'm being given just these two? My y is my opposite. I have opposite, I have hypotenuse. I have opposite and hypotenuse. This is what I'm looking for. That means I'll be using sine. So my y will be equal to what? Sine the angle to be equal to what? Opposite, which is my y, over what? Hypotenuse, which is 4. Now what is the angle given to us? That is pi over 4, and that is 45. So my y will be, my sine 45 degree will be equal to y over 4. Cross multiplying that, we have our y to be equal to what? Sine 45 degree multiplied by 4. Now calculating that in your calculator, finding sine 45 degree will give us 0.8509. Then you multiply your answer by 4. Then you have 3.400. Then approximately we have our answer to be what? 3. That means our x equal to 3 and our y equal to what? 3. So then you come to your question here. Then you tell us that converting this to Cartesian, that means you have what? Your point to be what? 3, 3. That is just it. So let me give you a brief formula, small formula that will help us in calculating for our x and y. That means if we are looking for our x, we do what? We do what? We do r cos alpha. Then if we are looking for our y, we do what? R sine alpha. So anytime you are being given any question, you just what? Pick your r that will be in your question, then multiply it by the angle given to you in the question. You get your y. So that's very simple. So you need to take note of this formula for calculating your x and y. If you want to change from Cartesian to polar, you do the one I've told you about, and if you want to change from polar to Cartesian, you use the formula I'm giving you. So now this is simply converting from polar to what? Cartesian, because this one will be giving is your Cartesian plane. You need your x and y to get, and if you want to get x and y, this is the formula you use. After getting your form answer, you then go and fix it back in the question that getting your polar is now so in Cartesian plane. So that is that. So that is that about conversion from Cartesian to polar and from polar to what? Cartesian. Now if you want to transform or convert from Cartesian to polar, this is what you will use. This is the formula you will use. They would have given you your x and y in the question. Then if you want to change this to polar, that means you want to calculate the angle and the r. Now calculating for the angle, you make use of this formula. Tan alpha will be equal to what? Your y given in the question over your what? X given in the question. Then you make use of a punch your calculator and then get your answer with time. Make sure it is the angle you are looking for. So not tan your angle, it is the angle. So you do what? You multiply through by the what? The arctan of the angle. So that will eventually give you something like arctan y over x to get your final answer for your angle. And if you want to get for your r, you know your polar form is always in the form of what? P r comma your angle. So with this formula now you would have gotten your angle, and with this now you want to get your r. So calculating for your r, you just squared your x that would have been in your question, and then squared your y that would have been in your question, then find the square root of it, the addition of the two Cartesian plane that would have been given to you. Then if you come to this side, that means you want to change from your polar to what? Cartesian. Cartesian is always having what? X and y, like this. Now if you want to find your x and y, and in the question you are being given r and your angle, so calculating for your x and y, what you simply do is what? Use this simple formula. Your x will be equal to what? Your r that would have been given to you in your question, cos your angle that would have been given to you in your question. And don't forget your alpha in any question given to you. When they give you pi is what? 180 degree. And with using this formula, you get the value for your x, and then find the value for y. You do what? Y equal to what? R sine your angle given to you. So the angle given to you and the r was have been given to you, then you punch your calculator and you get your value for y. So that means you have changed from polar to Cartesian, and this will help you. This formula will help you to do what? Change from what? Cartesian to what? Polar. So that is the beginning of geometry, and I hope the next class will be treating the area of triangles in terms of coordinates of its vertices. That means when you want to find the area of a triangle, and you have been given coordinates of the triangle on the graph, not the triangle we know very well like half base times that, you have been given the coordinates on the graph. So how can you find the area of the triangle? We'll make sure we treat that in our next video, and I promise you, you will enjoy it. So what do you need to do now? What you need to do now is to just hit on the like button and subscribe to our channel, and so that you'll be notified of the next time we'll be having our dropping the video for the next class. Thank you very much.